Now let us move on to the next topic. The same strategy in dynamic programming, we will look at reliability design. Now this reliability design problem is also is somewhat similar to the knapsack problem of dynamic programming, how we have seen. Instead of tables, we have taken sets and computed the knapsack problem. The same way, even reliability design, we are going to take sets and compute that. Let us look at what the actual problem is. Now this has the concept of this reliability design and has come up from the manufacturing process. So what actually we have is, suppose if we have to complete a task and we need D devices to we need n number of devices to complete that task, and each device is connected in series. That is, device 1 is connected to device 2, is connected to device 3, and so to device n. What happens is, in this case, if one device fails, the process is stopped. The manufacturing process is halted. So what we need to do is, we need to create such a process. We need to apply such a strategy that we get a higher reliability. So when the devices are connected in series, n number of devices connected in series, even if one device fails, the entire process stops. So it's not reliable. So to solve this problem, at each stage, there will be multiple devices connected of the same model. So the below part in each stage, stage 1, stage 2, stage 3 till n stages, what we have is, in series we have D1, only one device, D1 connected. But in stage 1 we connect 3 devices of same model, that is D1. In stage 2, suppose we are connecting 2 devices. In stage of same D2. Stage 3 we are connecting 4 devices. Same way in stage 3, let us say we connect 3 devices. So here what happens here is, even if one device fails, we have other devices. For example, if one device from stage 3, that is D3, one D3 device fails, we have other D3 devices which can continue the process. So connecting multiple devices in parallel at each stage is going to improve the reliability of the system instead of connecting n devices in series. So that is what is a reliability design problem. But we cannot just start adding number of devices in parallel. For example, we cannot add some 20 D1 devices. We cannot add some 50 D2 devices, so that even if 40 goes down, the process continues. We cannot do that way because the devices cost some value. So, and we have limited cost. We cannot start buying machines and all connect in parallel. So if you consider this, suppose if we have, if the in terms of computer science, you may say that the office has 3 monitors and then 2 hard disks for storage and 4 printers. Assume that. So even one hard disk fails, we have the data process content continue from second hard disk. If one monitor fails or 2 monitors fails, we have 1 monitor, still the reliability is better. We can continue with that. And then if 2 printer fails, no problem. We have 2 more printers so that the process can continue. But the problem is how many devices we need, or how much is the cost for them, and what is the reliability we will achieve. So let us look at some of the terminology that is used here in reliability design. We will be, just a second, let me just remove these unwanted things from here. Anyway, let us continue. So we have some terminology that needs to be used. The stages are same. There will be some number of devices connected at each stage. Now we will have sorry about that. Now we have some formulas here, just like knapsack problem. That is to find the reliability. Phi is considered as the reliability. So reliability is nothing but the product of reliability of device M1, Mi, where I is from 1 to n. So n number of devices are there. And then these devices cannot exceed the cost we have at hand. And cost of each device is Ci, and Ci multiplied by each device Mi. That summation should not exceed C. And here, how many devices to use at each stage, consider at each stage, depends upon a formula U. That is, we say U number of devices. U1 means those many devices at stage 1. U2 means those many devices at stage 2, and so on. So we have a formula to compute how many devices can be used at each stage. And that formula is nothing but C, the total cost, what we have, plus Ci minus summation of Cj of all the devices divided by Ci. This is going to give us the number. And this obviously is going to be it's going to be a floating point number, a decimal number, and we cannot use 0.5 device. We have to use the whole number as a device. So we have to actually consider. So we have to actually consider how many devices can be used. Then all this, since reliability is also an optimization problem, and here the optimization part or criteria is to maximize the reliability of the system. Now these equations what we have here, this is just like similar to a knapsack problem, where in knapsack we maximize the total profit, and that total profit was profit of each item multiplied by its weight, whichever is included. The same way here also we have these equations. Let us take an example and then find the reliability. Now here, first and foremost thing is we have cost for each device. Let us consider we have the 3 stages in our system, and each stage will have some devices known as D1, D2 and D3. Now how many D1s to put in that stage, how many D2s to put in that stage, and how many D3s to use in that stage has to be computed. So we have the cost for each device. Here we will be given the cost of each device. D1 is 30, D2 is 15, D3 is 20. And reliability also of each device. That is, reliability obviously cannot be 100%. We cannot say any device to be 100% reliable. So reliability is just like a probability there. So reliability for each device is here, for D1 it's 0.1, 0.9, D2 0.8, D3 0.5. Now we need to, and we are also given the total cost. We have at hand the total, like total capacity for the knapsack, we have total cost here. Now this total cost or maximum cost we can have is 105. Now we need to compute the U value of U. That is how many U's of D1 can be used, how many U of D2 can be used, and how many U's of D3 can be used. That is what we have to find. Now to do that, we have an equation for UI, which I have told you last in the previous slide. Its equation is C, which is 105, plus CI, that is cost 30. If UI we are trying to find, that is how many D1 devices can we place. So I is 1. So CI minus summation of 1 to n of Cj divided by Ci. So here first let us find this summation because it's going to be used everywhere. Summation is nothing but the total cost. The total of cost of each device. D1 is C1, cost to C1, for D2 cost to C2, for D3 cost to C3. So cost is 30 plus 15 plus 20. So that summation which we have is 65. So now let us find U1. How many devices? How many number of D1 devices we need? That is U1 we need. U1 will be C, which is 105, plus C1 is 30 minus 65 divided by 30, because C1 is 30, which gives us 70 by 30. That's 7 by 3, and 7 by 3 is 2 point something. But we cannot take point of the device, fraction of the device. We have to take a whole device. So it is, it's the floor value. So U is going to be a floor value for any decimal we get. So it's going to be 2 in this case. So we can use 2 devices of D1 at that stage. Same way for U2, we use the same formula and compute. Here C2 is 15, that is the cost of D2. So we get 50 by 15, that is something known as 3 point something. Its floor value is obviously 3. So we will be using 3 D2 devices. And then U3 is computed. It's going to be 60 by 20, which is 3 itself. So 3 D3 devices we will be using at that stage. So we will be given number of stages, and at each, and the devices we are representing as D1, D2, D3 for 3 stages. We will be given the cost, we will be given the reliability, and we will be given the maximum cost we have at hand, 105. It's actually, we cannot spend more than 105 to buy these devices. So how 105 is spent is according to the cost of each device, and that is we are getting computed through a formula, and we get 2, 3 and 3. Now what is the reliability? We have to find the reliability of the system. So for that we will be using this formula, phi of I of Mi, which is nothing but 1 minus Ri. Ri is the reliability of each device. So if we are trying to find reliability of device 1, at stage 1, we will be having 1 minus Ri, which is 0.9 Ri, because I is 1, power Mi, where M lies between 1 to U. That is, we can use only one device because we have 2 devices at most we can use. We can use one device, find its reliability. Or we can use 2 devices and find the reliability at that or of that stage. So first thing is we will use a set S0, same how we have seen in knapsack problem, which will have the tuple as 1, 0. That's the initial. Now here 1 represents the reliability and 0 represents the cost. 1 represents the reliability 0 represents the cost. And we start at stage 1 where D1 is the device and we can use at most 2 devices. So R1, which is the reliability, is 0.9 and C1, which is the cost, is 30. So we find set, obviously the device the number can be 1 less than equal to M1 less than equal to 2 because at most 2 devices can be used. So taking device, only one device, let's say M1, we will compute the phi value, that is the total reliability. So phi 1 of 1 is going to give us 1 minus, that's the equation, 1 minus R1 is 0.9 from the table, we are given that. Power M1 is 1. So this gives us the reliability as if you computed 0.9. Then if both the devices are used, if 2 devices are used at stage 2, we have to use M2 as, M1 as 2 and then we have to compute that. So that will give us different reliability. But before proceeding that, we have set S0. We will compute after adding one device, D1, one device D1 in the system. We will find what will be the value of the set S11. S11 means this R1 comma C tuple has to be applied to the S0. So S11 set is nothing but it's the set S0 with R1 comma C1 included. So here S0 is 1 comma 0. This 1 comma 0, because we have to include this R1 comma C1 tuple in that. So first thing is reliability. Remember in knapsack we have added both the values. But here reliability we are going to multiply R and cost we are going to add. So reliability at this 0.9 and when we added R1 comma C1 1 and the cost is added, which is nothing but 30. Why 30? Only one device is added. So its cost is 30. C1 is 30. So it's going to give us 30 multiplied by 1. That is only one device is added. This value is going to be S11. Then we will take, because at most 2 we can have, so one more device D1 can be added. So M1 will be 2. So phi, using the same value, phi of 1, phi 1 of 2 is computed. That will be 1 minus 0.9, that is Ci, that is the reliability, power 2, because M1 is 2. And this gives us the reliability as 0.99, much better than. So if we are including 2 devices, we are saying we have a better reliability. Now we need to compute S12. Remember the subscript, the superscript is for stage 1. The subscript for the set is nothing but as it represents the number of devices which are added. So now we again take this 1 comma 1 from the initial set S0 and we will use the reliability as 0.99, which we have computed 5, that is multiplied, and we are considering M1 as 2, that means 2 devices we are including. So plus the cost of the device is 30, but we are including 2 devices. So each device cost is 30, so 30 multiplied by 2, we are going to get 60. So this value will give us the element of set S12. Now, is there any more devices we can add of D1? No, U is 2. So U1 is 2, so we can add at the most 2 devices. Now, we are done at this stage. We have to now compute S1 set. S1 set. At S0 set, we started by adding the first stage, adding device D1. S1 we will compute for second stage. So S1 will be union of S11, values of S11, elements of S11 plus S11, union of S11 and S12. So both these elements forms a part of S1. Then since S1 we have to add the second device, and that's its reliability is 0.8 and its cost is 50. Now here they can be at most 3 devices of D2 that can be added. So what we will be doing is we will compute M2 using 1, that is only one device. So we have phi 2 of 1, which will be 1 minus its reliability is 0.8 over 1 because M2 is 1. So this gives us 0.8. So we will be computing S2 of 1, which will be S1 value, first value is 0.9, for first element is 0.9, tuple 0.9, 30. So this is reliability is multiplied by 0.8 and we get 0.72 as the result, and 15 is the weight, 15 is the cost, and only one device is used. We are computing only for one device, using one device, so 15 multiplied by 1. That is added to 30, which will give us this element, which forms the first element of S12. Then we have another element in the set, 0.99 and 60. So even for this, we will multiply the reliability and add the cost. So cost is nothing but 15. And here also we are using only one device at this stage, so which gives us the value as 75. So this tuple becomes the second element of S21. Then we will consider this 2 devices D2 in second stage. We will compute phi 2 of 2, which will be 1 minus 0.8 over 2 because M2 is 2, which gives us 0.96, and we will be computing set S22. So we will use the first value of S1, multiplied that, its reliability, and we will have the result as 0.86 and add its cost. So 30 is the cost from the first stage, and in the second stage we have D2, its cost is 15. So 15 multiplied by 2 because we are considering 2 devices to be there in the system. We will get 15 plus multiplied 2 is 30 plus 30 is 60. We get the first element of set S22. Same way we take the second value from S1 and we compute its tuple or its element. Here also we get the value of S22 and the element which we add. Then M3 also has to be computed because they can be M2 equal to 3 also has to be computed because they can be at most 3 devices we can place. So here the equation will be same, except that the power will be 3 and it gives us a much better reliability. Same way we will be computing S23, these values, by multiplying the reliability and adding the sum. Remember here we will be using 15 is the cost multiplied by 3 because we are considering 3 devices at this stage. So now we get the tuple or the elements of set S23. S23. So we are done by calculating the reliability, taking 3 nodes, and we get the set S12, sorry, not nodes, 3 devices D2 at second stage. So we get set S2 of 1, S2 of 2, and S2 of 3. With this union of these three sets will give us the set S2. Now let us arrange these ones according to increasing order of reliability. Now here we have to look at one more case where, in the above elements, we did not have this problem because all these constraints were satisfied. But here in this case, now obviously for these three elements, they are appended in the set S2. For this element, that is this tuple, 0.95 as the reliability and 90 as the cost. So 90 is the cost. We are including S1 means are computing S2 of 2. At S1 stage, we computing S2 of 2 is nothing but we have included some devices in stage 1. We included some devices in stage 2. Until now, we got the cost as 90, total cost as 90. Now, the cost of the third node device is 20. Now, obviously, to complete the whole system, I obviously have to include at least one device D3. Otherwise, my process will not get complete. My system is not complete. So, at least one device in each stage has to be included. Now, 90 is the cost we got so far. If I add the 20 to this 90, that is the cost of the third device, it becomes 110. And it is beyond C, beyond the total amount of money or cost I can spend, that is 105. So this tuple will not be considered. This element will not be considered. Because if it is considered, there will not be any way of adding device D3. So this is not going to be considered. The same way, this is the element which is added because satisfy the constraint. But 0.98, 105 as the cost will not be included because cost is 105. 105 plus the cost of the third device is, at least if one device we include, is going to be 20, which will be 125, and it's not crossing our constraint that C is 105 and it should be less than equal to C. So this element also will not be considered. Then now let us look at adding the third device, R3, C3, which is with the reliability as 0.5 and 20 as the cost. Now U of 3 is 3, that is at most 3 devices we can use. So we will be computing for by adding the third device. So we'll be computing set S3 actually now. Now before that, we have eliminated some of the elements here. In the same way, we just let us look at S2 set before proceeding further. There are certain elements that can be purged. It is the same purging rule that is applied in knapsack. Now let us look at this tuple or the element with a reliability 0.79 and cost us 75. And its beside tuple, which has a reliability as 0.86. Reliability is increasing, but cost is 16, which is decreasing, and it's not possible. So this cost is decreasing, whereas the reliability is increasing. So according to purging rule, we will eliminate the preceding tuple of the element. Then I suppose the rest of the elements are okay because Here's 0.72, here 86, reliability is increasing. We have cost is 45, cost is 60 here, it's increasing, no problem. Then we have reliability 0.86 and 0.89, which is increasing, and cost 60, and here we have 75, which is increasing. So there's no need to purge any other element. Now we will start with M3 as one. Same way we will continue its reliability. Here R3 is 0.5. So we will compute its reliability. We will be computing for this 0.72 and 45. Then we will continue with 0.86 and 60 and 0.89 and 75. The same way we multiply the reliability and add the cost. M3 is 1, so only one device is added. So we have 20 multiplied by 1. We get the results. I'm just going to skip through all the calculation and come to the part where we have where we will find what is the maximum reliability. So if you, this is my final calculation. Here remember that when we have M3 as 3, that is the third device, 3 devices we are using. So cost is 20 multiplied by 3 we use. So for S31 we multiply cost by 1. S of 32 we multiply cost as 2 because 2 devices are used, and S33 we multiply the cost with 3 and add it to the previous value. So here we got 3 sets, S31, S32 and S33. Now let us look at what is the maximum reliability and how many devices can be used at each stage. Now before we proceed further and looking at how many devices can be used at each stage. Now remember, U is nothing but is the maximum number of devices. At most we can use, and stage 1 2 devices of D1, stage 3 3 devices of D2, stage 4 stage 2 3 devices of D2, stage 3 3 devices of D3. So let us try to create a set S3 by union of set S1, S31, S32 and S33. Now all here also we consider, we will add elements sequentially according to reliability, increasing order of reliability. So far we have included all the elements of S31. There is no problem with respect to the cost. But here, why is this not working? Now for S32, 0.54 and 85 can be included, and 0.65 and 100 can also be included, but here 0.63 and 105 is included. And then because I said we'll arrange it according to increasing order of reliability. So instead of 0.65, 0.63 is lesser, so we have included this element of S33 before 32. Anyway, 0.65 is also included, its cost will be 100. Now what about this remaining? Its cost is 115. It's more than 105, so this is eliminated. The cost of this 0.75 is 120. So this also is going to get eliminated. Then 0.78 cost is 135, so even this is going to get eliminated. Now we are left with 1, 2, 3, 4, 5, 6 values of S3. And no more devices are there, all the stages are completed. Now, which one is giving us a high reliability? Before that, let us try to apply purging rule so that let us see if some elements can be removed or not. So here 0.633 and we have 0.43 which is increasing, so no problem here. 6.5 we have, 8.0 we have, it's increasing, no problem. Here 4.3 is the reliability, we have 4.5, it's increasing, reliability is increasing, no problem. We had 80 as the cost, 95 we have in this element, increasing, there's no problem. But in this, the next two, reliability is 0.45 and here reliability is 0.54, which is increasing. But here we have cost as 95 and 90 here as 85, which is decreasing, so which is not possible. So we will eliminate the preceding tuple or the element. The same way, let us look at the other things. Here we have one more problem. We have 0.63 is the reliability, 0.65 the reliability for the next tuple, which is increasing, but we have 105 and we have weight as 100, cost as 100, which is decreasing. So this, the preceding tuple is going to get eliminated. Then we are left with these elements of which, and we have already arranged it according to increasing order of reliability. So the last element, whichever is remaining in the set S3, is going to give us the maximum reliability that we can achieve. So its reliability is 0.65. And the total cost which is incurred, and the total cost which is incurred is 100. Now, how did we get this reliability? By including what? How many devices in each stage? So let us now compute that. We got this 0.65 and 100, this tuple, from S32 because it's containing S32. Now S32 means we are including, we have computed this when D3 devices, when we were using two D3 devices. So M3 is going to be 2. That is, at stage 3, though we can use at most 3 devices, but to get this reliability 0.65, that is the highest reliability, we include 2 devices, or we use 2 devices for at stage D3, at stage 3, and those 2 are D3 devices. Now, let us trace back. Now, this 0.65 and 100 we got by using 0.86 and 60 tuple, this tuple. Now, this tuple is found where? In S22. That S22 means we have the S22 result or the elements when M2, that is D2 device. That is, we are using 2 D2 devices. So at stage 2, at most we can use 3 devices, but we get reliability 0.65 by using 2 devices, and that's the maximum reliability we have. Remember that. Then how did we get 0.86 and 60? By obviously using 0.9 and 30 as the element. Now you maybe just thinking that how it is, I'm saying that we got this by 0.86 and 60 we got this. Why? Because this is the second element of the set. So obviously the second element we got by multiplying the probability, by multiplying the reliability and adding the cost. To whom? Second element itself. So this is the first element. This element is, eliminated. So this one is the second element. So that is why we have the second element of S32. So here, this 0.86 and 60 is the first element of 2, set S22. So obviously, when this is first element, we got this by multiplying the reliability and adding the cost to the first element of set S1. Now, where is this 0.9 and 30? 0.9 and 30 is in S11. And this we got it obviously by considering M1 as 1. So, if you look at the problem or the optimal solution for this problem, we can use one device D1 in stage 1, two devices of D2 in stage 2, and two devices of D3 in stage 3, which will give us maximum reliability of 0.65, and the amount we need to spend, or the cost we need to spend for these devices is 100. It is 100. So this is the reliability design problem. That is, we have to find how many number of devices can be placed at each stage so that we achieve maximum reliability. So this is an optimization problem, and optimization is to maximum the reliability of the system.